Here in this little demo, I'd like to demonstrate to you how to solve the practice problem that you saw at the end of the module using Excel. So I've pasted all of the ANOVA formulas here into the Excel spreadsheet, and we're just going to walk through them one by one. So the sum of squares total is equal to the sum of all the x squareds, which was given in the problem, minus the g squared, g is given there, divided by n, the total n is 15. So we're just going to come down here to where it says the source is sum of squares total, so this cell right here, sum of squares total, and we're going to type equals this cell with the sum of x squared, minus, and then open paren, because we need everything on this side of the formula to happen together before it's subtracted from this value. So we're going to put here on the inside of the parentheses 60 times itself divided by big N right there. And then we close our parentheses, push enter, and that's our sum of squares total. Our sum of squares between is equal to the sum of each t squared divided by n. So we come over here and we recognize that what we're going to do is square this t and this t and this t, each individually, and divide each one of those by their own respective n's. So down here I'm going to put this t squared divided by n, just as a reminder of what I'm doing. And I'm going to put equals the t times itself divided by n. Okay, so this is the first t squared divided by n, this is the second t squared divided by n, and the third squared. So once we have each of those t squareds divided by n, then we can sum them up. And I'm just going to do that over here off to the side. I'm going to do the sum of those three. And I'm just going to put a little reminder note here. In the review tab, I can put a little note that says this is the sum of each t squared divided by n. All right. Now we have to take that component and subtract from it g squared divided by n. So I'm going to come down here to where it says sum of the squares between in this cell right here, and I'm going to type equals the value of all those t squareds divided by n summed up minus the g squared divided by big N. So minus, open parentheses, g times itself divided by n, and parentheses, enter. That's your sum of squares between, 70. Now your sum of squares within is to take the sum of squares inside each treatment and add them up. So this is my sum of squares for treatment 1, for treatment 2, for treatment 3. I'm going to come here and I'm going to say this equals this plus this plus this. Or I could have written it like this. I could have said equals the sum of all three of those. And it's going to be 60. So you notice that your 70 and your 60 add to 130. Okay, your degrees of freedom are going to be computed. The total is big N minus 1. So I'm going to come down here and I'm going to say equals big N minus 1. I'm going to come here to between and write k minus 1, the number of treatments, k. There's three treatments. 3 treatments minus 1. You can just put 2, or you can write equals 3 minus 1, whatever you want. And then when you come to here, when you're doing the degrees of freedom within, it's the sum of n minus 1 for each group. So we come up here and we're going to take our n's and subtract 1 from each of them. I'm going to carry this across, so now we've got 4 and 4 and 4. And if I add those up, I can write equals the sum of 4 and 4 and 4. And as I mentioned in the lecture, the sum of 2 and 12 come to 14, so you know that you're on track. The next thing we need to do is compute our mean squares, which is the same as variance, SS over DF. So for this cell right here, we just take the sum of squares in this row divided by the degrees of freedom in this row, equals SS over DF. And then we do the same thing in the next row. I can actually just carry this right down. I don't even have to retype the formula. And then for your F, of course, down here we have that mean squares between divided by the mean squares within. And so we've got mean squares between and mean squares within. All I have to do is divide that by that. And we get 7. That's our f.